Tech Talks Education. Let us continue with the formation of ions, and in particular, let us look at formation of anions. It is a continuation of what we have been doing. Just to remind you briefly, we said that anions are formed by only what? Non-metal elements. This one we saw it. And we said that the atoms of the non-metal elements consist of 4, 5, 6, 7, or 8 electrons, and in this case we are removing those non-metal elements with 8 electrons in their outermost shells because they are what we call the noble elements, in that they are inert, they don't react, so they can neither lose electrons nor gain electrons. Even the one with the 2 electrons in its outermost shell, that is helium, also does not react. Therefore, helium, neon, and argon are among the noble elements or the inert elements among the first 20 elements. So, for them, they don't form ions completely. Otherwise, the rest of the non-metal elements do form ions, which are called anions or negative ions in this case. So, we said that these anions are formed by the anions as a result of the complete loss of electrons from the outermost shells of atoms of non-metals. The complete loss of electrons. So that one results in the number of electrons. So it is not the complete loss of electrons, but the complete gain of electrons. So the complete gain of electrons is in such a way that the outermost shell becomes full. In this case, the number of electrons gained must be some number that fills the outermost shell, so that the non-metal atom acquires a noble gas configuration, which is either 2, that is only for hydrogen, or 2 to 8, that one is for, that one is for other elements other than hydrogen, from number 4 up to number 9. All the electronic configurations of the ions that they form results in 2 to 8, and then 2 to 8 to 8 for elements from silicon up to chlorine. That's from number 14, the one with atomic number 14, up to the one with atomic number 17, minus argon. So these resultant electronic configurations are what we call the noble gas configurations, which are either duplet if it is 2, and then octet if it is 2 to 8 or 2 to 8 to 8. That is what we saw. And we said that the number of electrons gained must be some number that fills the outermost shell. And the number of electrons gained is equal to the number of negative charges on that particular anion. And for that reason, in an atom, which is an anion, the number of electrons is more than the number of protons because of electron gain. So let us look at this table here quick. Seriously, we have got non-metal atom. We are going to look at its atomic number. We shall have a look at its electronic configuration. Electronic configuration. We shall look at formula of the ion formed, and then we shall have finally electronic configuration of the ion formed, which is going to be either duplet or octet, as we have already seen here. So let us look at element which is hydrogen. The atomic number is 1, the electronic configuration is 1. Now, since hydrogen has 1 electron in its outermost shell and it is a non-metal element, In this case, it is behaving as a group 7 element because the outermost shell is just the first shell, which requires 2 electrons in order for it to be full. So that means it requires just only 1 electron to fill it. That's why it is also regarded, or it is taken to be under group 7 elements in the periodic table, because those group 7 elements requires just only 1 electron to fill the outermost shell, just like hydrogen also. So the ion formed will be an ion formed as a result of the gain of 1 electron to fill the outermost shell, and the atom becomes negatively charged with 1 negative charge, and this is what we call a hydride ion. So the electronic configuration of the ion formed in this case is 2. That one is a duplet configuration because 1 electron will be added here to fill the outermost shell. The next element, this one is hydrogen. Let me use the chemical symbols. The next element is helium is not among them because a helium atom is an inert element. In this case, it is an atom of an inert element, so we don't put helium. We go straight to carbon. Carbon has got atomic number 6. The electronic configuration is 2 to 4. And in this case, we can see that the outermost shell of a carbon atom requires 4 electrons in order for it to become full. So those 4 electrons are gained, which is equal to the valency of carbon, which is 4. So a carbon atom therefore becomes negatively charged on gaining the 4 electrons. So it will become negatively charged with 4 negative charges. And then the resultant electronic configuration will be 2 to 8, since 4 electrons are gained to fill the outermost shell in this case. That is carbon. Let's go to nitrogen. The atomic number is 7. The electronic configuration is 2 to 5. It requires up to 3 electrons to fill its outermost shell. So when the 3 electrons are gained, which is equal to the valency of nitrogen also, then the nitrogen atom becomes a nitride ion with 3 negative charges. And the resultant electronic configuration here will be also 2 to 8. So that one is for a nitrogen atom. You can see that 3 electrons are supposed to be gained, which is equal to the valency of nitrogen, which is 3, or it should be the number of electrons required to fill the outermost shell, which is 3. And because of that, if 3 electrons are gained, then there will be 3 negative charges on the ion of nitrogen, which is called nitride ion. And the resultant electron configuration is now not 2 to 5 but 2 to 8 because 3 electrons are gained. Let's go to oxygen. An oxygen atom has got atomic number 8, electronic configuration of 2 to 6. It has to gain 2 electrons equal to the valency of oxygen, or it requires 2 electrons to fill its outermost shell. And when those 2 electrons are gained, then the ion of oxygen, which is the oxide ion, will be having 2 negative charges with electronic configuration of 2 to 8. I hope we are moving on well. Let us look at the next one, that is the fluorine. Fluorine, the atomic number is 9. The configuration is 2 to 7. And this atom of fluorine requires just only 1 electron to fill its outermost shell, which is the same as the valency of fluorine. So when it gains 1 electron, it forms the ion, which is the fluoride ion F minus, and the configuration becomes 2 to 8 on gaining that 1 electron. So that one is for fluorine. We were supposed to go to neon, but remember that neon has got electronic configuration of 2 to 8. Its outermost shell is full with a valency of 0. So it doesn't need any electron to fill the outermost shell because the outermost shell is already filled, or it is full. So we don't take neon as one of the non-metal elements that can form an anion. So we go to silicon with atomic number 14, electronic configuration 2 to 8 to 4. So a silicon atom will have to gain 4 electrons. It is a non-metal. It gains 4 electrons and becomes negatively charged with 4 negative charges. And the resultant electronic configuration will be 2 to 8 to 8 in this case. You can see that it gained 4 electrons here, which is the same as the valency of silicon, which is 4. And in this case, on gaining the 4 electrons, it becomes negatively charged with the 4 negative charges and with the resultant electronic configuration of 2 to 8 to 8. That's the electronic configuration of the ion of silicon. Let us go to phosphorus. A phosphorus atom has got atomic number 15, electronic configuration 2 to 8 to 5, and the valency of phosphorus is 8 minus 5, which is 3, meaning that a phosphorus atom will gain 3 electrons and that will fill its outermost shell. So when it fills the outermost shell, then the phosphorus atom will be having 3 extra electrons or 3 excess negative charges. That is a phosphide ion with an electronic configuration of 2 to 8 to 8. 2 to 8 to 8. That is for phosphorus. Next is sulfur, atomic number 16, with a configuration of 2 to 8 to 6. So the sulfur atom requires only 2 electrons to fill its outermost shell. So the sulfide ion formed will be having 2 negative charges equal to the valency of sulfur, which is 2. And the resultant electronic configuration of the ion formed will be also 2 to 8 to 8. Then we go to chlorine, which is the last one among the first 20 elements. A chlorine atom has atomic number of 17. The electronic configuration is 2 to 8 to 7. And if that is the electronic configuration, you can see that it requires only 1 electron to fill its outermost shell. So its valency is 1. So when it gets that 1 electron that fills the outermost shell, the chlorine atom becomes a chloride ion with 1 negative charge, and the resultant electronic configuration is 2 to 8 to 8 also. So all these ones are octet configurations for the nonmetals. In this case, after forming their anions, they assume what we call the noble gas configurations, which are octet, ending in 8. It is only hydrogen which, on gaining 1 electron as a nonmetal or as a group 1, as a group 7 element, a nonmetal, it will have to assume a noble gas configuration of 2. That is the duplet configuration. So in general, we must just remember that in an anion, in an atom which is an anion, the number of electrons is quite more than the number of protons. In this case, because of electron gain that takes place. So this is how anions are formed by some of these non-metal elements among the first 20 elements. I believe that we have understood this, and this is Tech Talks Education. I believe that we have got something here. Thank you for watching.